I didn't get a fire video for the nice free movie, but the camera is still.
All right. All right, take a look at the top. We're gonna do just a little bit of geometry before we move into your notes for today. So we're just gonna do the triangle on the left. So we should have two other little marks here that didn't get copied. But what do those marks mean? Not parallel, but I know what you mean. They're the same, or congruent would be, right? The word we're looking for. So 7 and 7. And if I know two sides, that means I can use Pythagorean theorem to find the third side. Do we remember what that formula is? Okay, a squared plus b squared equals c squared. Now, out of the sides listed, we have a 7, and then the missing side. Which of those is the c? The missing side. Very good. So when I set it up, it's going to be 7 squared plus 7 squared equals c squared. Remember that the c has to be the hypotenuse. Okay, and then in the calculator, I'm going to add those two up. So it'll be 7 squared plus 7 squared. That gives me 98. And if 98 is c squared, what's my next step? Take the square root. Now, at this point, the square root of 98 is correct, but it's not simplified. So to simplify, you'd have to look up that list on your notes from last time. I know it's been a while, but can anyone, without us getting out the paper, what perfect square could 98 divide by? It's already on your paper. Oh, wait, no, it's not. Never mind. What is 7 squared the same as? You know, 7 squared is 49. And so 98 is 49 times 2. And then what's the square root of 49? 7 root 2. Okay. So I guess I'll go ahead and get out that list just so we have it for the rest of the notes.
Well, this list will be separate.
I'm sorry?
Well, could this be on a separate piece of paper?
Sure. Yeah. All right, now for number 2, I want to ask you, could you use Pythagorean theorem to solve this second triangle? No. How many sides do you have to do Pythagorean theorem? 2. So we're going to put can't use a squared plus b squared equals c squared unless you have 2 sides already. Okay, so if you get a triangle where you're only allowed to have one side, really Pythagorean theorem is not going to work. There are other methods that we'll learn in this unit on triangles, but for right now, you've got to already have 2. All right, so we are going to go back to geometry. Let's put computers away, please, just for right now. So when you were in geometry, you learned sine, cosine, and tangent. Okay, the abbreviation is SOHCAHTOA. Does anyone remember what the SO stands for? Sine equals what? Opposite over hypotenuse. Okay, so that's SO, S-O-H is sine opposite over hypotenuse. Okay, ca is cosine, and it's adjacent over hypotenuse. And then for tan, it's opposite over adjacent. Okay, then where the hole punch is, the symbol for your angle is going to be a theta, which is that little circle that you see with the line through it, here, here, and here. Okay, so theta is the symbol used to represent the reference angle. Okay, so now let's talk about real quick what all those words mean. So the hypotenuse we already talked about last time. Remember, that's the one that's across from the right angle. It's the longest side. Okay, so the hypotenuse is always the longest side. It doesn't matter where your theta is. Okay, for the adjacent and the opposite, both of these are legs of the triangle. But the adjacent side is going to be touching the angle theta. So the adjacent is touching angle theta versus the opposite is not touching theta. Now, why is it not touching? Because it's opposite from it. It's across the triangle from where the theta is. Okay, so let me show you what I mean. We're going to redraw our triangle right here just a little bit littler so that it can all be on the same screen. So I have a 7, and then do you remember up here that my third side was 7√2? I'm going to put 7√2 right here. Okay. It says that we want to place theta in the corner where the B was. So looking back at the original triangle, do you see that B is this bottom corner right here? So I'm going to draw my theta in right here. Okay, first thing I want you to do is put an H on the side that is the hypotenuse. Where should I put the H on the triangle? Which of those three sides? 7, 7, or 7√2? Which one is the hypotenuse or the longest side? The 7√2. Okay, now if you don't know how to tell, remember wherever the 90-degree angle is, that's touching the two legs. So the one it's not touching, that would be the hypotenuse. Okay, out of the two sides that are left, this is the adjacent side because it's touching the corner where theta is, versus the other leg is the opposite side because it's not touching the theta. Okay, and then I'll write this is hypotenuse. Okay, so let's say that I want the sine of theta. Then I would do so, ka, or toa if I want sine. Sine is so it's going to be O over H. And then in your triangle, what is your opposite side? What number? 7 over, what's your H side? 7√2. Now, we'll come back and simplify these later, but for right now, we're just going to write them out. Okay, for cosine, cosine is ka. That's adjacent over hypotenuse. What's my adjacent side? Over 7√2. And then for my tan theta, it's so ka toa, which is O over A. 7 over 7, very good. Okay, now, which of those can I divide evenly? 7 divided by 7 is how many? 1. That's your final answer. Okay, now, last class we talked about that you're never allowed to leave a square root in the denominator of a fraction. So notice that for your other two, they both have a square root on the bottom. Let's review how to fix that. You're going to take your square root of 2 and you're going to repeat it on bottom. But if you're going to put it on bottom, you have to also put it on top. Remember, that's the rule. So on top now, I have a 7√2 over. What happens when I root 2 and then root 2 again? Do you remember what we get? Regular 2. Very good, because the square roots basically cross out. So root 2 times root 2 is a regular 2 times by what here in the front? 7. So 7 times 2 makes that a 14. And then for the last step, now that the 7 and the 14 are both on the outside of a square root, I can divide them with each other. Okay, what is 14 divided by 7? 2. So it's going to be root 2 over 2. Okay, and if that was kind of confusing the way that I did that, you can still divide these, but then just put the answer on the bottom because that's where the bigger number. Okay, now because these match, this is the answer for both the sine and the answer for the cosine. So my answer for both of these is gonna be √2/2. Okay. All right, for triangle number 2, since we couldn't solve it, I'm gonna give you a different triangle, okay, so that we can still work through this same process. So draw me a little triangle right here. We'll let this side be 12. We'll let this side be 6. And we'll let this side be 6√2. Your ABC is still going to be in the same position that it was. But this time, where am I going to place my theta, for example, 2? Which letter? It says right here, we're going to let theta be in corner A. So that means that my theta is going to go up here. Now, out of those 3 sides, which one is still the hypotenuse? The 12. Very good. So I'm going to put in H for hypotenuse. Okay, out of the 2 remaining legs, remember your legs are always touching the right angle. Okay, which of them is touching theta to be my adjacent? Is it the 6 or the 6√2? This is the adjacent, which means that my 6 is the opposite. Okay. Then from there, we're going to go through our SOHCAHTOA. So remember, sine is O/H, cosine is A/H, tan is O/A. So it's SOHCAHTOA. And then we're going to pull the sides off the triangle to create our fractions. So for sine theta, I want opposite over hypotenuse. What numbers will I use?
6/12.
6/12. Very good. And then I'll come back and reduce all these later. Let's just write them out first. Okay, next I want A/8. What will that be? 6√2/12. Very good. And then last one is O/A. What's that going to be? 6/6√2, correct. Okay. Now, for the first one, 6/12. Okay, can we divide 6 by 12? Not really. Can we divide 12 by 6? Yes, what would you get? So you just basically make it 1/2. Remember, the 2 goes on bottom because the bigger number out of the 12 divided by 6 was on the bottom. Okay, for the next one, for cosine, I still have a 6/12. But notice that the only difference is that my top also has a √2. Okay, so look at that, see if that makes sense. The 6/12 is becoming the 1/2, and then I'm just keeping this √2 on top. Now, question, why don't I have to fix the placement of the √2 in the cosine answer?
It's already on the top.
It's already on the top. Remember, where are we not allowed to leave them? On the bottom. So now let's take a look at the third one here. I see that I have a √2. That's not allowed. So to fix it, I'm going to put another √2 on bottom and a √2 on top. So what I have right now is a 6√2 over 12. Very good, because here's what's happening. √2 times √2 becomes a regular 2, and then I times it with a 6 in front of that to get the 12. Okay, which means in that case, okay, I'm looking at those numbers in the front. What can I do with that? Yep. 6 and 12 can both divide by 6. 6 divided by 6 is going to turn that into a 1√2, and then 12 divided by 6 is going to go to it.
So we don't need the one in front of the √2.
You do not need a 1. These actually are the same. So Delta Math will count it right either way. If you want to put the 1 in the front, you can, but you don't have. Okay, any kind of questions on that? Okay.
How do we over cosine?
So cosine is A/H. The adjacent side was 6√2. The hypotenuse was the 12. And then because we had numbers that were both on the outside, we can divide them with each other. So 6 divided by 6 went to 1, 12 divided by 6 went to 2. Okay, when you turn the page, you're gonna notice your triangle has how many sides labeled? Only 2. So go ahead and find the third side for me real quick, please. Okay, so you have a 6 and a 3, but you're missing the other side. So for the next example, set up your Pythagorean theorem, find that third side. Is everybody good with this? Can I take this page off? Can someone tell me what their equation says just to make sure it's right? 6 squared plus 3 squared equals 6 squared. Okay, then remember you got a calculator. So 6 squared plus 3 squared is going to give me 45. And then from there, we're going to have to take the square root. Okay. Now, since we're going to need that list, I'm going to just pull mine out. But if you have your notes from last time and you want to get it out for you for your homework, that would be great. All right, so here's the list. Okay, I'm looking for a number that 45 can divide by. Remember, you want to start close to where the number is and then work your way up. So 45 can't divide by 49. Can't divide by 36. Can 45 divide by 29, 25? 16? 9? 9 times what? 9 times 5. So I would break it down into 9 times 5. But remember, in that step, they're both in their own square root. But then the square root of 9 is a perfect, what is the square root of 9? 3 root 5. So on my third side here on my triangle, I'm going to put 3 root 5. Okay, from here, they're going to tell you what corner to put the theta in. What letter are we putting the theta in for this one? Corner C. So that's going to be here. Okay, and then what I'll usually do, just to make sure we remember which one are the legs, okay, is wherever your right angle is. See how this one's kind of tilted sideways? Remember, the legs are always touching the right angle. So the side you didn't highlight, that's your hypotenuse. So I automatically know this is the hypotenuse.
Did you get from 9 and 5 and 5 again?
We looked on the list of the perfect squares from last time to see what 45 can divide by.
All right.
So 9 times 5 gives us the 45, but then the 9 is perfect. That's where the 9 goes to 3. Okay, so my 3 root 5 is the hypotenuse. Out of the 2 legs that are left, which one is adjacent or touching the theta? The 3 or the 6? Which one is adjacent? The 6, which means that the 3 is the opposite. Okay, then from there, your homework is going to ask you to find sine, cosine, and tangent. Remember, it's SOHCAHTOA. So sine is so, cosine is ha, tangent is oa. Okay. So for my my O over H, what are my numbers going to be? We'll reduce them later. What's O over H? 3 over 3 root 5. Adjacent is A over H. What's that going to be? Over 3 root 5. And then tan is going to be OA. What's my OA? 3 over 6. Okay, then looking at all of those answers, okay, which one of those am I going to have to fix where the square root's on the bottom? Which ones? Sine and cosine. Okay, now for this one, you can go ahead and put it in your calculator if you want, but 3 and 6 can both divide by 3. What's that going to reduce to when I divide by 3, top and bottom? 3 divided by 3 is 1, 6 divided by 3 is 2. And then that one's done, because it doesn't have the weird square root on the bottom. So let's go back to sign. I noticed that I have a root 5, it's on the bottom, we know it can't stay there. So I'm gonna repeat the root 5 on bottom, also put it on top. So what we have at this point is on the top, it's a 3 root 5. What number will end up being on the bottom? Very good. Root 5 times root 5 again gives me a regular 5. And then I would times that with the 3. That's where the 15 comes in. Okay, now that both of these numbers are on the outside, I can reduce them. Okay, I can either cleanly divide it or divide them both by the same number. 3 can't divide by 15, but 15 can divide by 3. What would I get? 15 divided by 3 is 5, but the bigger number's on the bottom, so it'd be root 5 over. But if it's easier for you to think about it this way, you're dividing by 3 top and bottom. Okay. And then again, if you want to write the 1 here, you can, but you don't have to. Okay, take a look at the next one. Have a root 5 on bottom, got to fix it. So root 5, root 5. The top is going to be a 6 root 5. And then on the bottom, root 5 times root 5 is regular 5, times it by the 3 is a 15. Now, for this one, 6 can't divide by 15, 15 can't divide by 6, but they can both divide by what? 3. So then you divide by 3 top and bottom. 6 divided by 3 is going to go to a 2 root 5. And then 15 divided by 3 will be a regular. Okay. Kind of remember that a little bit from geometry?
No.
No. Okay. So those are the 3 principal trig functions. However, there are actually 3 more. Okay, cosecant, secant, and cotangent. Okay, the way they're organized on your paper is that they're across from their partner. So come down here to the bottom and then we'll do the example. Okay, CSC refers to cosecant and it is the reciprocal of sine. Reciprocal just means that you're going to flip it. So if sine is O over H, CSC is H over O. Okay, but you're literally just flipping the fraction. Secant or SEC is cosine's partner. So if cosine is A over 8, then SEC is H over A. And then tangent and cotangent are also partners. Tangent is O over A. So what will cotangent be? A over O. Very good. So the good news is that it's really the same 3. You're just flipping them. Okay. All right. So take a look at the top, back at that example. Okay. At CSC is already across from its partner. So if CSC is going to be O over H flipped, then it's going to be, now one thing I do want to say is flip it before you fixed it. Okay, and the reason why is my original answer was this. If I flip it, is the square root 5 going to still have to be fixed? No, because when I flip it, it's going to end up on the top.
Oh, so you don't have to flip the result.
Correct, because now think about what if I flip this one? Then my root 5 that I just fixed to get it on top is going to end up on the bottom. I'm going to have to fix it again. So flip your original, not your fixed. So for example, if this is 3 over 3 root 5, now it's 3 root 5 over 3. My original answer for cosine was a 6 over 3 root 5.
3 root 5.
So it'd be 3 root 5 over 6. And then for my last one, I didn't have any square roots in that. Then I can just flip the final product or flip the original. It doesn't matter. So just to be consistent, if this was a 3 over 6, I'm going to switch it to a 6 over 3. And then Oliver, just like you said, that will divide the 2.
Oh, I just flipped the answer.
That's fine, yeah. Okay, then out of the other two, what can happen on the CSC if there's a 3 top and bottom? Yeah, 3 divided by 3 is a 1 root 5. Put the 1 or not, that's up to you. And then 3 out of 6, we know 6 can divide by 3. What would you get?
5.
Over 2, very good. Because remember, 6 divided by 3 is 2, but since the bigger number's on bottom, you keep the answer on the bottom. So you have your original 3 and then your reciprocal 3, which are the originals just flipped. Okay? Ooh, thank you. All right, go ahead and turn the page. This should have been a 5. I wrote the wrong number down.
Just as I finished writing down the page.
Oh, so sad. All right, only 2 more left.
Yeah.
2 more left, and then we're done. Okay, let's say that instead of them labeling the triangle for you, they give you a value of so, ka, or toa. So for this one, they tell you that the cosine of angle A is 2 over 5. Is cosine so, ka, or toa? Cosine is ka. So then I'm going to have to go to my triangle and put in the adjacent and the hypotenuse in the correct sides. Now, where does my theta go? Which corner? A, so my theta is here. Then the first thing I'm going to do is highlight the 2 sides that are touching the right angle. Okay, remember these are the legs. Which means that my hypotenuse is this side right here. And what number am I going to put on the hypotenuse side based on the fraction? H is the bottom, so it has to be a 5. Okay, the A stands for adjacent. And remember that adjacent is touching the theta. So if my theta is down here, that means this is the adjacent side and it is a 2. Which means the side that I'm missing is the opposite side. But since I already have 2 sides, how can I find the third side? Using starts with the H. Oh wait, no, it doesn't. It starts with a P. Pythagorean theorem. Thank you. Okay, will I set it up like this? 2 squared plus 5 squared equals c squared? No. How would I have to set it up?
3 squared plus b squared.
Very good. Okay, 2 squared plus b squared equals c squared. Okay, remember, you have to have all 3 sides to do your SOHCAHTOAs. So will I add the 2 squared and the 5 squared in my calculator, or will I subtract it? Okay, so I'll do 5 squared minus 2 squared. 5 squared take away 2 squared is going to be 21. And then I take the square root of that. And then check my list. To see, can 21 divide by anything? Okay, so here's your list. And remember, you start at the number, work your way up. 21 cannot divide by 25. Or 16, can 21 divide by 9? What about 4? No, then we're going to leave it. So root 21 is just going to stay. That's your answer. So label that on your opposite. And now let's set up our fractions for SOHCAHTOA. Sine is O over H. Cosine is A over H. Tan is O over A. Once we have those written down, let's put our numbers in. What will the fraction be for sine, which is opposite over hypotenuse? What will I write down? With the numbers. Okay, root 21 over 5. And then while I'm at it, let me flip that and fill out CSC. What would the answer here be? 5 over root 21. Because remember, they're already across from their partner, since you don't really know who's partners yet, probably very well. Okay, cosine is A over H. What will A over H be? With numbers. 2 over 5. Which means that SEC will be what? 5/2, because remember, they're reciprocal partners. That means you just flip it. Okay, and then last one, O/A would be √21/A is 2. That tells me that for cotan, I would just flip that and do 2/√21. Now, out of those answers, which are the only two that I'll have to actually fix? Sine the square root's on the top. Remember, we like it on top. Where do we not want it? On the bottom. So my CSC, huh?
Oh,
If it's on the top, you're good. You can leave it.
are you sure that?
And then this one, yeah. The other 4, though, are all done. So this one's good. This one's good. This one's good. And this one's good. All right, let's fix 5/√21. To fix the √21, we're going to repeat it on the bottom and also put it on top. So now I have a 5/√21 on top. What do I have on bottom? √21 times √21 is a regular 21. And then you would look at the front numbers and see if they have anything in common. Okay, can 21 divide evenly by 5? Do they have anything they could both divide by? No, then you're done. Okay. Bottom one here, same process. If I have a √21 on the bottom, I'm going to repeat it. But if I put it on bottom, I have to also put it on top. So my answer is going to be 2√21 over regular 21. And then when I look at those front numbers, if they have something in common, do it. But if they don't, you can leave it. Okay, in this case, 2 cannot divide into 21. They also both don't have anything in common. All right, last example. Okay, tan theta is 7/5, and your theta goes in the B corner. So I want you to look at that triangle and place your sides where you think they go. And then we'll do it together in a second. So your theta needs to go in corner B. Think about what your opposite, adjacent, and hypotenuse
How
are.
do we know it goes?
Because it says your theta is a B. And it
I
says
can see that.
that's okay. So put your theta in the B corner. And then I want you to label your hypotenuse, opposite, and adjacent. And then put your 7 and your 5 where they go. So your theta should be here. Your legs have to touch the right angle, which means that your hypotenuse is going to be over here. What will this side be? The opposite or the adjacent? Adjacent, because it's touching the theta, which means the other side is the opposite. Okay, then once you label that, think about the side ratio for tangent. Tangent is TOA, which means 7 is the opposite, 5 is the adjacent. So my 7 goes here, my 5 goes here. Before I go on, I have to find the missing side. How will I do that? Pythagorean theorem. So it'd be 7 squared plus 5 squared equals. Okay, and your calculator, 7 squared plus 5 squared gives us 74. And if 74 is c squared, then I'd take the square root of that and get √74. Sometimes that number can break down, sometimes not. Okay, and then in this case, I'll just tell you it can't. You could try all the numbers, but none of them will divide, which means I can leave this as a √74. Okay, then from there, I know this is going to be O over H, A over H, O over A. And then remember that these guys are the flippies. I will just take the originals and flip them. Huh? You could do 2, but 2 is not a perfect square. You need to do 4. You know what I mean?
Yeah.
Okay, so sine is O over 8. What are my numbers? Can I go ahead and box that answer, or am I gonna have to fix it? I'll have to fix it later. Root 74 over 7 though, that one's good. Okay, because remember, square roots on bottom are no, but on top it's fine. Okay, A over H is gonna be 5 over root 74. I'll have to fix it, but root 74 over 5 is good to go. Then O over A is 7 over 5. Those numbers don't have anything in common for me to reduce. And then cotan would be 5 over 7. Then out of the 2 that you have to fix, you'd repeat the bottom root. That'll give you 7 root 74 over 74. Okay, because remember, root 74 times its own self, you just keep the number. Now, for this one, can you just tell me what the answer will be without us doing it? Very good. And if you can do that part in your head, I don't need to see you show the work every time. But it'd be 5 root 74 over 74. Okay, do we feel like we can do that? Okay, go ahead and pull out your Chromebooks. Start, please, with the scratch paper on the back side of your notes. And then I'm happy to bring you more if you need it. Okay, I just opened your homework. So you should be able to see it now. Okay, now one thing I want to point out to you is when you first look at the homework, it might be like, oh my gosh, it's a million questions. Okay, all of this KLM is the same triangle. You're gonna find the missing side, then type in sine, cosine, tangent, CSE, blah, 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 okay? So the whole first KLM, those are all the same triangle. So as you're writing it out, do it just like we did in the notes. Then all of your ABCs, that's the same triangle as well. Okay?
There's no photo.
What? For which one? For KLM?
Oh, that doesn't show.
None of you? Okay, then I'll just leave, draw it on your scratch board. Sorry. Okay, and then y'all, like if it's saying find LM, it's asking you to find that third side. And then after you find the side, it'll have you go through the trigs. Can you have it drawn? Can I take it off of here? Okay. Okay. And then were you already using that? Okay. Did you know that? And then you'll have to ask your old teacher to bring you to the class. I don't think you can drop. What was your name? Oh, sorry.
Yeah, because they have the.
Uh-huh. So you have the hypotenuse right and your theta is here. This has to be on 3 and 2 has to be. You only have 3, so when you get to the next one. Yes, ma'am. For 13, and then your L would be opposite over hypotenuse. I think you have your sides labeled wrong. So on this one, your L is your theta, yeah? Correct. And then this is your hypotenuse. This is your adjacent. Does that help? So then it'd be 2 over root 13. Which would go to that, yeah. It's the same picture as this one. So if you're doing CSC of L, CSC is which one flipped? Is it part? Because you know how they're across from each other? So CSC is partner in sine. So whatever your answer is for sine, you'll flip it for CSC. Yep. Yes. And then did they tell you which one to put the theta in on that one, Nate?
Oh, yeah.
Okay. So then once you know that A is your angle, that'll help you decide which leg to look at. That would be the hypotenuse. Right?
Yeah.
Yeah. Are you so confused or no?
No.
Okay. I'll put it back up there. Will you just draw it? They just are gonna pick a side. So if they put an A in the equal spot, you know that's the thing. And then think about like Caitlin, like the hypotenuse, no matter where you put the thing, that has the thing, the only difference is for the leg. You have to know where theta is, you know, what I'm talking about. Yes, ma'am. So you know your adjacent, so your A is your theta, so you put your theta there. And then remember that your adjacent side would have to be the 3 on top and your H has to be the 5. So then this is your adjacent, your hypotenuse, that will give you enough to find your opposite.
I don't know, that's behind
Okay, so let's write on your thing, put your root 13 here. This is the hypotenuse, so put an H there.
Well, wait, where's theta?
So it has to tell you, I think they said to put it in L. So see up here how it says L, I think you're on sine.
Yeah.
Okay, so now think about it, if your L is your theta. This is my theta. Then this is my hypotenuse, which I think you said it was root 13, is that correct? So then out of these two that are left, out of these two legs, which one is adjacent to theta or touching? This is your adjacent, which then means that this is your opposite. And so then if you're on sine, is that so, ka, or toa? Correct. So then if this is O over H, what will your answer be? Which side?
It would be, 2 over the square root of 13.
2 over root 13. And now before I go on, I would think about if sine is 2 over root 13, I'm gonna have to fix it. But what will CSC be? And it's gonna ask you for that later. So that's why I would try to do like all 6 kind of at the same time and then type them in once you're done.
Okay.
So this one, what will it be when I fix it?
How do you fix it?
So remember a square root on the bottom, you're just gonna repeat it again, but if you put it on bottom, you have to put it on top. So what am I gonna put here? Another root 13.
Wow. Sorry.
And then what is root 13 times root 13 again?
Yeah.
It'd just be a regular 13. If you put the same root twice, you just
And
get
then what is the 2?
it'd be 2 root 13. So that's what you would type in for that answer. We did 2 root 13 over the. And then do the same thing for the other 4. Yes, sir. Sine would be opposite over hypotenuse. Yeah, it would be 4. Good job. Uh-huh. Who was that? Sorry, okay.